Would be lonely without you. Kent asked me to tell you just a little bit about our chapter for 2 seconds. Most of you are already members, but if you're a member, why don't you raise a hand? People can look around and see all the members, lots of members here. If you're not a member, we have 2 flyers on the display. One of them is entitled The Climate is Changing Now. We should too, and it talks about our organization. And the other one talks about the program that we're advocating, which is a carbon fee and dividend. And if you're not familiar with that term, this will explain it to you and tell you all you need to know about carbon fee and dividend. We have 16 chapters of Citizens Climate Lobby in the state of Wisconsin, and we have over 300 chapters around the nation, and some of those are around the world. We have them in several other countries as well. The idea is that we are a nonprofit, nonpartisan organization designed to try to keep this a livable planet. That's what we're about, and the way we're going to try to do that is by getting Congress here in the U.S. to pass a revenue-neutral carbon fee and dividend. So if anybody wants to talk about that, I'd be glad to discuss it with you. If any of you would like to get information about our organization, I'm going to just hand this around. If you just pass it back, if you're already a member or are not interested, and we will be happy to give you any information you want. Any questions? Then I will turn this over to Kent. Kent.
Thanks much. I'm Special Event Chair, and we have Special Event Committee members here. Dave Airy in the back, Dave, Joyce and Dave Kachuris right here. And we thank you for showing up. We try to have 3 of these special events each year. Of course, CCL is the sponsor. Co-sponsors are the Aldo Leopold Audubon Society, Baja Faith, Frame Presbyterian Church Green Team, Interfaith Community for the Earth, ICE, Midwest Renewable Energy Association, North Central Conservancy Trust, Peace United Church of Christ, Stevens Point Area Retired Teachers Association, Stevens Point Parks, Recreation and Forestry Department, and Stevens Point Unitarian Universalist Fellowship. Did I mention NCCT is also a co-sponsor. I've been communicating for some time with Steve Handler, and this is what he gave me to mention to you about himself. Steve is a climate change specialist with the USDA Forest Service, Northern Research Station, and Northern Institute of Applied Climate Science. His main role within IACS is to coordinate the Northwoods Climate Change Response Framework, which involves building partnerships, assessing climate change risk, and working with forest managers and landowners to develop real-world projects to adapt and prepare for future change. Stephen moved to Hope, Michigan in 2011 and claims to be a fond, loving yupper. He's going to speak to us about climate change in Wisconsin Northwoods forests, what we know, what we expect, and what we can do to adapt. Steve Handler.
Thanks a lot. Thanks for the introduction. I turned this microphone on. Can you guys hear me? Okay?
Yes, we're supposed to.
Yeah. Okay. Well, if you have trouble hearing me in the back, just give me a thumbs up or something. Tell me to raise the volume. Thanks a bunch for having me here. I appreciate you guys taking the time to learn about something new. In the middle of the week, this is a rare thing for me, and this is the fun part of my job. I like doing these kinds of talks. So I hope you guys brought your questions. I already got mobbed by a group of people right away in the back who are super interested and enthusiastic and more educated than me on a lot of forestry issues. So I'm sure this is a knowledgeable crowd. So I want to answer this question first. And this is maybe one that I don't have to spend a lot of time on for a group like this. But somebody told me once, always motivate your presentation, right? Always answer this question first, so what? And I think it's pretty obvious here. why do we care about forests and how they may be affected by climate change? And one of the reasons I love doing what I do is that forests provide us so many benefits. There's such a diverse array of values we get from our forests and wetlands all across the state. So whether you're mostly interested in water quality or recreating in a forested environment, whether you care about hunting and fishing, care about habitat for forest-dependent wildlife, whether you're interested in a legacy to pass down from generation to generation if you own forest land, you have a reason to care about forests. And also, forests are a valuable part of our economy here in Wisconsin and throughout the upper Midwest, right? They sustain us economically as well as ecologically, culturally, spiritually. So I want to hear really quickly from you all why you're here. How many of you own forest land? A lot of you, okay? How many of you work for or used to work for an organization that dealt with forest management or conservation? Some of you, academia? Yeah, okay. How many of you don't know why you're here? Sure, you're here for the cookies. Okay, yeah, I think this is one thing we can all agree on, that we all have a stake in maintaining the health and vitality of our forests. And in Wisconsin, you guys are blessed with a huge diversity of kinds of forests, from lowland conifer swamps, northern hardwoods, down in the south you have grasslands and savanna transitions, right? So there's this immense diversity. And your forests are across the state of Wisconsin. Wherever you are in the state, you're not very far from a forest, right? This is why we live here and not Kansas. This is why Kent and Sue moved to Kansas, right? And I put this chart up on the side too to remind us that, again, this is an issue we all have a stake in because more than half of our forest land in Wisconsin is owned by families, okay? Federal government, like Forest Service, manages only about 10% of the forest land. State DNR is about 7%, and local, like counties and other municipalities, manage about 15%. And so between public land and private land that families own, gosh, that's a huge proportion of our forest land that we're all invested in.
Can you explain other private?
Other private is private industrial or tribes. Yeah. So the other thing that I probably don't need to spend a whole lot of time on in an audience like this is that there's a clear connection between our climate and the kinds of forests that grow here. Climate, in a lot of ways, sets the boundaries of what can thrive, what can survive in an area. So we know what we expect of a northern Wisconsin climate. Right? We expect 4 distinct seasons. We expect these cold, brutal, terrifying winters that keep the Floridians down in Florida. And ecosystems are used to this too, right? They evolved to take advantage of these 4 seasons, to tolerate the winters, right? So the connection between the climate setting the boundaries for what's possible in our ecosystems is really clear. So, before I jump into climate change, I should say that I'm going to probably just give you the highlights today. Some of the stuff maybe you've already heard, some maybe you won't have heard much about. If you want to do some more deep dives and learning about this subject, I brought a couple of things. I brought a stack of these white books. It looks like they're all gone from the table, so if you want one of these, you can have this one. But this is a report that is kind of like a soup to nuts story of how forests might be affected by climate change in northern Wisconsin. So where are forests now currently and how do they exist? What kind of climate change have we already experienced over the past century? What's a range of future climates that are plausible for northern Wisconsin? And then how does that affect forests? What's likely to change? What's most at risk over the next 100 years? That's all here in this report. So if you want more get one of these books, get this one, or borrow from somebody, or send me an email, because these are free. They're downloadable from the internet also as PDFs. Even more information, I was just handed this report too, Wiki here in your own state, Wisconsin Initiative on Climate Change Impacts. Many of you are probably familiar with that group. They have put out really nice reports like this one on climate change impacts. They have a chapter in here on how it might affect forests. So that's another great resource. And then I mentioned another Forest Service website, Climate Change Resource Center. So if you just open up Google and type in Climate Change Resource Center, this one is a website that's devoted more towards the land management crowd. But if you own forest land and you're pretty savvy about what goes on in your woods, there's a lot here that will be useful for you as well. Okay, so just very briefly to set some of this up. We're talking about climate change here, so what do I mean when I talk about climate change? I heard a fun fact a couple of days ago that Wisconsin, in December 2015, had the warmest December and the wettest December in the history of the instrumental record. Now, in the past 120 years, we've never had a warmer or wetter December than we had in 2015. And you guys lived through that. You're probably not too far in your distant memory, right? So what does that tell us about climate change?
Here it is.
Here it is. What does a really warm and wet December tell us?
No snow.
Yeah, there was no snow.
The El Nino is working hard.
The El Nino is working hard, right? And that kind of gets to my point, is that a warm month is really just a product of a weather phenomenon. That's that strong El Nino that is producing this warm December. A day, a week, a month, a year, even a decade, this is really just driven by variation, randomness, fluctuation in our weather patterns. That's weather, right? That is here today, gone tomorrow. That's like, I tell people that weather is like your mood, climate is like your personality. So I'm putting a couple dots here on the screen here. This is a graph of Wisconsin average temperature for the month of February. And I'm showing February 2014 and 2015. How many of you remember February 2014? What do you remember about it?
It was very cold.
Very cold. What are the two words you remember about February
Polar
2015?
vortex.
Polar vortex. Yeah, somebody would say it. Yeah, and that really bore out. Both of these winters were top 10 coldest winters in that instrumental record. 2014 was 9 degrees Fahrenheit below our long-term average. 2015 was 8.8 degrees below our long-term average. So very close, both really cold. And I'm showing you here a picture of the whole planet for February 2015. And our local experience here in the Midwest, boy, that was really noticeable across the whole planet. We were the cold spot, right? So we were the only ones suffering in that polar vortex. The thing that jumps out at you, aside from that blue dot, is that everywhere else was warm, right? So this is another thing about weather, is that it's really variable place to place to place, right? So not only is it random in time, it's random in space. So this picture also isn't telling us a whole lot about climate change, right? This is a blip on the radar screen. This is an aberration. So I'm pulling back the curtain a little bit. Same graph. Average temperature across the state of Wisconsin for the month of February for the last 15 years, from 2000 to 2015. What do you notice about this graph? What strikes you? Yeah, in the green sweater?
Most of it's above that gray line, which I assume is 0.
We'll get there. Yeah, most of it's above the gray line.
Normal.
Yeah. What else?
Variability.
Yes. Huge variability. As much as 15 or 20 degrees Fahrenheit from year to year to year in what our Februarys bring us. right? Huge variability. So even at this decade scale, or even longer than a decade, 15 years here, the main signal we're getting is randomness, right? This is still mostly a weather-driven period of time. And it's like you're playing roulette, right? Imagine that if you land on black, you get warmer than average. If you land on red, you get colder than average. Okay, that's our year-to-year random weather experiences. And so now, pulling the curtain all the way back, you were right about the gray line, that it is our average. It's not zero. So this is our long-term average. Over that 120-year period I was talking about, this is our instrumental record. So now, we have decades and decades and decades stitched together. We have a long time series. So now we have enough information to begin talking about climate, right? When we have enough time, and usually we say 30 years at a minimum is what you need to be talking about climate. So here, now that we have enough information, we can start to talk about what's normal, what's our average, what's our expectation here. And the average temperature here is 16.5 degrees Fahrenheit across Wisconsin for the state of February. The other thing we can do now that we have enough information all stitched together, that we have a long enough time, is that we can look at trend. We can look at how is that randomness changing over time? Is it changing over time? And here, so I'm putting the blue line on, that's the long-term trend. That's climate change. And the slope of that line is 0.5 Fahrenheit per decade, which doesn't seem like a whole lot, but over 100 years, that's 5 degrees Fahrenheit warmer. Right? So from now, or from the beginning of the century until now, our Februaries, on average, have gotten 5 degrees Fahrenheit warmer. And that's even with the 2 polar vortex years, right? Even with that huge variability. And so go back to the roulette wheel example, right? Every year we're spinning the wheel. Black is warmer, red is colder. But we know now that the underlying mechanics of the game are changing. We're changing the odds of this game. So it's like we're covering up some of the red squares with black. So every year that goes on now, if this trend continues, we have a better chance every year of hitting a warmer than average February. That's climate change. So we're changing the underlying rules of the game. Yeah, question?
Well, I understand what you're distinguishing between climate and weather, but I guess what I'm wondering if the trend is for it in the past 20 years, or even looking at that graph, it looks like, for the past 40 or 50 years, it's been getting warmer, right? That blue line's getting higher.
Yep.
So if warmer weather makes more severe storms, can you not say that the severe storms that we're experiencing now are in a way, in effect, a climate change?
Yeah, it's. I see the point you're making, and I get this question.
It's more real to people that
Yep.
Katrina,
Yep.
the reason why it was so severe was because of climate change.
Yeah. So can you attribute a severe storm or one big weather event to climate change? And I use the baseball player analogy. Maybe you've heard this one. So we've got Barry Bonds, who was always a good baseball player, but over the last decade of his career, his head started getting bigger, and he started needing bigger and bigger jerseys. Right? He was on the juice, and he was hitting even more home runs. Right? So, for a single Barry Bonds home run, was that a steroids home run, or was that background? He's a good baseball player home run. It's hard to say, right? And there is a lot of work going on into that science of attribution. And I've seen papers that look at, when we get a huge heat wave, we get a huge drought, we get a Hurricane Katrina, there are some researchers that are starting to put probabilities to that. Like we would have only had a 10% probability of a Katrina without climate change. So it's not all the way there. It's a direct attribution, but yeah, people are interested in that question. Anything else about this example? I'm guessing this is all comfortable for you all. Okay. So I wanted to skip through this too, because you guys have probably already heard a lot about what has already changed in Wisconsin. You know that Wisconsin has gotten warmer across the year. That's true across the Northwoods. Depending on where you are, different amounts of warming. So this is changes in seasonal mean temperature over the past 110 years, 1901 to 2011. Thing that's true across our part of the world and really all the northern latitudes is that most of our warming is happening in winter and spring, with very little change, more mild change in summer and fall. So really it's more accurate to say that we're getting less cold, right? Our cold seasons are getting less cold. With rainfall, this is more variable, what's happened across the Northwoods. Across the whole region, we've gotten wetter. We're getting more precipitation across the year, although Wisconsin and western UP is kind of an anomaly in that we've got this big drying area where we're getting less precipitation in the summertime. And I know foresters already have experienced this in northern Wisconsin. We've had a couple extended droughts over the past couple of decades. And we know it's not just how much rain you get, it's when you get it, it's how it's delivered. So this is a graph showing just those rainstorms that drop 3 inches of rain or more at one time. This is across the whole state of Wisconsin from over the past 50 years, so 1960 to 2010. And this trend is also clear across the upper Midwest, really across the whole eastern United States. We're getting more and more of our rain delivered in these big dumps, big pulses of rain. And that's just physics, right? Warmer air holds more moisture, it's more saturated, and when it rains, it all rains out of us. Even if we didn't have thermometers or rain gauges, there are lots of other lines of evidence that let us know that the climate is changing in Wisconsin. And you guys have read or seen these kinds of things, no doubt. So we've got lake ice duration changing. We've got less days of frozen ground each winter, more freeze-thaw cycles happening within a winter, and then growing seasons advancing earlier in the year, about a week since 1950, depending on what you're measuring, whether it's flowering dates or leaf-out dates or migration events. Many different things that people are monitoring and noticing that, yeah, the natural world is already responding to some of these changes in temperature and precipitation. This is a good spot for me to pause, since we're talking about forests in particular, and point out some of the other things that are happening. Okay, so yes, climate is changing, but it's not the only game in town. There's a lot of other stories that are unfolding that are really important for our forests in Wisconsin. So we've got high levels of deer across the landscape. These guys have to eat, and what they tend to eat is tree seedlings, and they have preferences, right? So they're preferentially eating. So they're manipulating understory composition in our forests in a huge way across the landscape. So this is a big deal. It's not that long ago that much of our forest land in Wisconsin, particularly that land that counties own now, used to look like this, right? It was cut and run, failed agriculture. So lots of the state used to look like this, and we're still recovering from that. Many of our forests, most of our forests across the state are really second and third generation forests. They're still recovering from this kind of historical logging boom. Not as big a deal in Wisconsin as it is in the West, but we also have this legacy of fire suppression. So over the last 80 or 90 years, we've gotten very good at controlling wildfires and extinguishing them as soon as they happen, rather than letting them spread across the landscape as they normally might. So this is a bigger deal in dry, sandy kinds of landscapes. And then finally, we've got critters like this. How many of you know this guy? Emerald ash borer, yeah. So we have pests and diseases like this that are introduced and that kind of run wild in our forests, and this is happening independent of climate change, right? The climate is not influencing the spread of EAB across the state. It's mostly transportation on loads of firewood and things like that. that's moving this guy around. So it's in Superior, Wisconsin. It's hopped over to Minnesota. It's in Iowa now. So this guy is moving outside of the climate. So we have all these other things happening before us. And this is not to say that layers of doom and gloom, right? But the point is that forests are dynamic, and they have always been dynamic, and they're responding to a huge array of pressures and pulls, one way or another, right? So we're adding climate change on top of this stuff. Not that climate change is necessarily overriding all of these, but it's playing in a concert with all these other things. So, what do we expect in the future for forests and climate change? I want you guys to help me out here, and this is a little audience participation time, because like I said, I'm just giving you the highlights here. I don't have time to really go in deep. So for the next 5 or 10 minutes, I'm interested to hear your questions, what maybe you've heard about a little bit, what you want to know more about. So I'll put this list up here. These are some of the highlights. These are some of those big impacts that when we get groups of forest managers, when we get groups of researchers together, and we look at model results and we look at general expectations on what climate change might mean for our forests, these are some of the things that always rise to the top and that people are concerned about. So we've got longer growing seasons, CO2 fertilization, changes in soil moisture, extreme weather events, less frozen ground, increased fire risk, species range shifts, and increased stress. So those are some of the major impacts, both good and bad, for forests. So what on this list have you heard about or are you interested in? Yeah.
Species range shifts, I've heard quite a bit about that. To be a little bit comical, if you like birch trees and brook trout, move to Linwood.
Yeah,
Maybe
right.
that's exaggerated with humor, but it's not totally false either.
Yeah.
And then I've also read where to design a forest for the future, because they take a long time to mature, obviously, but that we should be studying what's going on in the Ozarks, because that if we plan our forest future to be similar to the Ozarks, we would, I'll just say, we're doing our progeny a favor. What do you think?
Yeah, okay. So I'm going to go have some slides in here about all of these. Okay, so species range change. First thing I'll say is that if you're really interested in this, if you want to know what species might be winners, what species might be losers, there's a whole chapter in here and tables of increases and decreases for individual tree species. Chapter 5 in here. Okay, so if you want to zero more in, go into this. So how do we get a handle on this? How do we tell what tree species are going to be benefited or harmed by changing climate? Well, we have some tools like this, the Climate Change Tree Atlas. Have any of you guys heard of this Climate Change Tree Atlas? Okay, this is another one to write down if you want to go to Google and just type in Climate Change Tree Atlas. It's a really neat tool. You'll get information like this. So what the Tree Atlas does is it has information for individual tree species. Something like 140 tree species are built into this, and they're all on the web.
Wow.
So you can look up an individual species like white oak. And what the Tree Atlas does is it takes a picture, takes a map of where does white oak live right now. And we get this information from Forest Service data, from FIA inventory. So we know where white oak lives currently. So what the Tree Atlas does is it takes a list of something like 35 or 40 different variables that might explain why does white oak live there and not other places. And so some of the things the Tree Atlas considers are soils, obviously. I think they've got like 12 or 15 of those variables all have to do with certain soil characteristics. They've got things like elevation, slope, percent agricultural land, proximity to Great Lakes, all sorts of things like that. And so what they do is they describe statistical relationships that explain, which of these variables are really controlling why does white oak live where it lives. And some of those variables are climate variables. I think maybe 7 or 10 of those variables are things like January temperature, average rainfall. So we've got this description, and now it's a statistical model of why does white oak live here. And then so what the Climate Atlas does to predict the future is they take out those climate variables for present day, and they swap in those future climate variables. So projections of what is temperature and precipitation going to be at the end of the century. So they assume that all of those statistical relationships remain the same, and then they redraw this map. So if you plug in that new climate change information for the end of the century under a low climate change scenario, this is the future map you get for white oak. And I don't know if you can see the colors, but it's not a dramatic amount of change. You get some white oak kind of bouncing above the tension zone, particularly around Green Bay. In northern lower Michigan, you really see it jump. And in northern Minnesota, you start to see it jump. So there's more suitable habitat for white oak in the future in those places. And then under a high climate change scenario, so kind of business as usual, we keep pumping CO2 out into the atmosphere, this is what the future of white oak looks like. And it's a pretty dramatically different picture, right? So under that high end of climate change, there's a lot of suitable growing space for white oak in northern Wisconsin in the future. Now this is not a prediction. This doesn't tell us that all the squirrels are going to get together and march the acorns up to northern Wisconsin, but it does tell us the possibility. It tells us that the potential to grow white oak will exist. On the other end of that story, you've got some species that are projected to decline, like aspen. So here's aspen where it lives right now. Under a low end of climate change by the end of the century, it's not a whole lot of change between current and future. So a mild amount of climate change is really not that bad for aspen. On the other hand, a high amount of warming, and you see a big change. Those colors are a lot muted, or that it's kind of zapped all the way down to yellow. And so what that tells you is, it's not that aspen is all of a sudden going to burst into flame and all croak all at once, but it does tell you if aspen is left behind, if there's still aspen growing there at the end of the century, it's going to be growing further outside its comfort zone. It's going to be exposed to more stress from heat events, from droughts, and things like that. Okay, so we don't, so we don't say that this is written in stone, but this is an idea of possibility. Where's that pressure going to be? And you can probably guess some of those species that are projected to lose some suitable growing conditions. And there are some of our iconic northern species, like aspen, paper birch, black spruce. You guys fill in the list.
Maple.
Maple, I didn't put it in here. It's kind of between these two pictures. So like sugar maple, a little bit of change is actually no big deal. And even a high end of change for sugar maple, it's not as big a decline as what you see for aspen.
Okay.
There's still a lot of growing space for maple.
I misunderstood that.
Particularly, well, so that sugar maple and red maple is quite optimistic for climate change. Red maple is one of those that we expect to actually maybe flourish under climate change. Yeah?
What about the conifers? Like white pine?
I'm kind of going off the top of my head here, but generally we expect kind of white pine to do okay, if not even a little better under climate change. That depends which end of the extreme we end up on, but white pine is one of those that has a huge ecological tolerance. It can tolerate a lot of different conditions. It grows all the way down to southern states. So the models generally expect it's going to be able to handle some of these changes pretty well. Red pine is maybe a little more at risk than white pine, but it's more of an issue of if red pine is on a site that's good for red pine, then it's probably going to be fine.
What about walnut?
Walnut is more like white oak, where we see big increases in suitable habitat for walnut. Yeah. Okay, I'm going to leave the species one real quick. Any of these other impacts that people want to hear about? How about woman impact?
Maybe this goes under stressors. Are you looking at increased disease or insect migrations farther north of, things that you haven't seen before?
Yeah, so I kind of lump all that in this category of increased stress. So when we look at insects that do damage in forests, when we look at diseases or invasive species that are harmful in forests, there's not a lot of model projections and hard science and simulations that can really tell us what to expect. So we're more often operating kind of on our gut instinct for what change might mean for those kinds of things. And generally, if we're thinking about forests that are exposed to more stress and more variable conditions, then we anticipate more opportunities for those bad things to do harm. We know that pest outbreaks tend to be much more damaging if they occur on top of a drought, all right, for example. So there's potential for some of those pests and diseases to become more damaging. But we don't have a lot of research for individual species. Yeah.
Well, one of them right at the top of the list is longer growing season, and when you really start looking at just based on my own records of my own property over the last 38 years, and then trying to correlate it with things that are going on over a broader area, there's a number of different effects on it. For example, when we've had early springs, we've also tended to be in a situation where things come out early, plants leaf out, but you also tend to have cold air bottled up farther north, and then we get that mid to late May killing frost, which has an effect on blueberries and apples and a whole number of things like that, and really change the whole phenological pattern for those species. For in case of maples, apples every other year.
Yep.
Than the blooming seeds, fruit set, and so on. And then you go to the other end, and when you have falls that are mild much later than they normally are, our native flora is not adapted to a late fall, whereas the Eurasian exotics, which because of where the glacial refugia were, when they're introduced, are active October, November, even into December, and they are mostly invasives, and they represent an enormous threat in the shift of the understory in forest and situations like that. So longer growing is not a simple thing, and it's not a blessing. It's very much of a mixed bag.
Amen to everything you said. Yeah, I couldn't have said it better. And actually, that's like exactly what I had on my slide there. Your perfect plant. I think a buckthorn is a perfect example of a species that can take advantage of that longer growing season right now, or maybe it's going to take some of our native flora decades, generations to be able to adapt to that. So yeah, it's not a panacea, even though it could mean more time for growth. There are some risks that go along with it. Anything else on this list? One more question?
Is a pine beetle a concern in our forest?
Pine beetle. How many of you heard of mountain pine beetle? Some of you? Okay, a lot of you. Okay, so this is one that people are watching. And what I know so far is that, right now, mountain pine beetle is running wild in Montana and Wyoming, decimating their lodgepole pine forests. There's an area up in British Columbia and Alberta where jack pine bleeds into lodgepole pine. And historically, cold temperatures have kept pine beetle from crossing the continental divide. In recent years, they have picked up pine beetle on the other side of the divide. So it's speculation now, but it's a risk. If pine beetle is able to transition to jack pine forests, then there's just a continuous swath of jack pine running from Alberta to Wisconsin and Michigan. So it's kind of a what if, but it's looming. Okay, I'm gonna jump through the rest of these and talk about adaptation. Because I didn't want to leave you guys on, oh gosh, this big list of threats. Because a big part of my work now is dealing with this question. So what? So what can we do about it? And forestry is one of those cool issues where we have both opportunities to respond to climate change available to us. And by that I mean mitigation on one hand, right? So forests, we all know this, they play a hugely valuable role in our Earth's carbon cycle, soaking up CO2, storing that CO2 in place in forests, in forest soils, even in long-lived wood products. People think of those as carbon stores, right? So this cycle, forests are responsible for sequestering 10 to 15% of our greenhouse gas emissions annually. And huge volumes of carbon are stored in forest ecosystems and particularly in forest soils. So it's immensely important to pay attention to forests for this mitigation angle. Mostly, however, what I deal with is this issue of adaptation. Okay, and I take a very broad definition of adaptation. That is anything we can do to prepare for climate change. What actions can we take now? So what can we do now to prepare for climate change? And we tend to think in these three general buckets. You have three large choices to make when it comes to climate change adaptation. And this is in forests, this is in city planning, this is in human health, any field you want to think about. You have these kinds of choices. And they span kind of a continuum from resistance, which is kind of like it sounds. It's playing defense. It's building up the seawall in New York City, right? So if you have something really valuable that you want to protect, then you can play resistance. To the other end of the spectrum, transition, where you're actively encouraging change based on what you think the future is going to be. So you're intentionally changing a system to give yourself a better chance of success in the future. And then in the middle, there's this big basket of things called resilience. And I tell people to think of resilience as kind of like building some elasticity into a system. So it can take a punch, it can take some stress, but then still bounce back. So in forests, just to give you a really quick idea of how some of these things play out, resistance is reducing stress that's already out there currently on a forest, right? So paying attention to pests and disease outbreaks, managing invasive species, trying to restore and rehabilitate systems after they've been damaged. Those things are all kinds of resistance kinds of approaches to climate change adaptation, and they make great sense, right? They're totally valid responses. In the middle, resilience, we basically think of like managing a stock portfolio, hedging your bets, spreading risk out. So that means managing for a diversity of forest types, a diversity of species in a particular place, a diversity of age classes, right? So you don't want to have just all old trees or all young trees. It's helpful to have a mix across the landscape. And then transition, some of the things you guys are probably thinking about, planting southern tree species, maybe even experimenting with different seed zones. So if white pine grows here and it grows in Illinois, maybe let's try planting some of that Illinois white pine to see if it's better adapted to future conditions. So those are just very quickly some examples that we work with forest managers on. And basically when we're trying to coach people through this, to help them come up with ways to adapt, we try to connect it back to those values that are meaningful for them. So if you care about your forest land as a revenue generator, an economic source, then there are ways you can continue generating revenue even under climate change. That gives you a certain set of things you could do to continue generating revenue. If you're concerned about hunting opportunities, well then it's time to think about what those critters need, right? Do they need cover? Do they need food sources? And can we provide those, even with climate change? So there's a bunch of different ways you can go. And the nice thing is that science is never going to be able to tell us exactly what to expect. So we tell people not to hold their breath and wait for a crystal ball. But the nice thing is that we don't need a crystal ball. Right? We don't need to have certainty in order to make decisions about adaptation. I use this Hurricane Sandy example a lot. So in a lot of ways, we're in a situation similar to this, where we're in maybe an early stage of this storm, and we have a tremendous amount of scientific information, model results, and just kind of gut level expectation about how the future might play out. And there is pretty big uncertainty there between the low end of climate change and the high end of climate change, right? But there's still this cone of possibility, right? We generally know the trajectory we're headed in. So really, we don't need to wait and figure out which exact storm track is the right one. We can make decisions right now to adapt. So if I'm a mayor, or if I'm a city council member, anywhere from Maryland to Massachusetts, I know enough right now to begin adapting. Right? I don't need to wait for the crystal ball. And whenever we work with forest managers, a lot of the discussion has to do with what is the identity of this particular place that you're managing, that you own, that you care about. Because all of these local factors, like species composition, or diversity, or invasives, or elevation, or soil type, all of these things that foresters are used to paying attention to, those are going to be crucial to deciding what's possible and what makes sense to prepare for climate change. I'm going to give you a couple really quick examples. So a big part of my work, like Kent mentioned in his introduction, is working with land managers to develop what are these real-world examples of climate change adaptation. Each of these dots represents a place where we've worked with an organization like a county or a tribe or the DNR or a national forest or a private landowner. And we've helped kind of coach them through a thought process on climate change adaptation. So one example is with the Menominee tribe. How many of you have been through the Menominee Reservation near Shawnee, Wisconsin? A lot of you. So they've got this immense reservation, 250,000 acres of beautiful hardwood forests, right? They're held up as the model of sustainable forest management. And they're dealing with this issue of oak wilt. How many of you have heard of oak wilt? Okay. Oh, wow. Okay. Is that a recent presentation or something? Okay. So they're chasing oak wilt across their reservation. They've identified something like 300 or 400 pockets of oak wilt. And they're getting in there, and you know how to treat oak wilt. You basically have to drop a bomb on that little patch of oaks, right? So they're treating this kind of like 300 different test tubes, 300 different little canvases that are blank right now. And so working with us, they picked 10 of those, 10 of the bigger ones with really good access, and they're using them as demonstration sites for climate change. And they're getting in there, and they're, instead of just allowing natural regeneration to occur, they're getting in there and they're planting some of those southern tree species, like chinkapin oak, for one example, which kind of dips into southern Wisconsin just barely, but most of its range is kind of in Appalachia to Missouri, and even further south. So they're getting in there and they're planting some of those species. Not all of them as extreme as this one, but they're using this as a chance to do kind of a common garden experience.
Is that chinkapin oak? Is that what
Chinkapin oak.
is that more resistant to the wilt?
It's, yeah, a lot of the ones they're picking are in the white oak family, so they're less resistant. Yep. So they're also looking at burnt oak, white oak. So that's one example. Another example I wanted to share with you is up in Florence County. So the county manages something like 40,000 acres of land. And I'm showing you this picture. It doesn't look like a forest, but it used to be a forest until recently. They had one of these big droughts, 9 or 10 years of drought, followed by a native pest outbreak, two-line chestnut borer. So they have a lot of areas that look like this right now. They used to be scrub oak forest, and they had 95% mortality in their trees. So we've worked with them on one of these sites. And we talked about what's possible here. You guys want to get this back to being a forest. But would you do anything differently now that you're thinking about climate change risks or opportunities? So they're concerned about the ongoing drought. They're concerned about future droughts. Particularly on this site, they have really sandy soils that aren't going to hold a lot of that moisture. So one of the things they're doing, which is kind of outside of the box, taking an example from agriculture or gardening, and they're actually thinking about, well, can we actually get in there and manipulate our soils? Can we do some soil amendments with compost and wood-based biochar? Can we get in there and actually incorporate some of this stuff into the soil so they have more water holding capacity? So we'll be in a better position to withstand a future drought. So we actually got some funding from Wildlife Conservation Society to do this on 130 acres across their forest. So they're now planting, you probably can't see this, but they're switching this area from oak to pine. That's one of the adaptation things they're thinking about, because this is a drier, sandier site. Switching it to jack pine, red pine, white pine. And then they're also doing these soil amendments. So a couple different ways to maybe give themselves a better chance of success. Those are my two examples. There are a bunch more, and many of them are with private landowners. So my last pitch to you all is, if you're interested in what might happen in your woods, and if you want some help thinking about it, that's part of my job. I get paid to work with landowners, help them think about these risks, and then put some actions in place, and then share those stories. So you guys are my target audience as much as anyone else. That's what I had for you. I've talked a little bit longer than I planned, but I can take questions as long as you guys want. Yeah.
Excellent.
Thanks.
Question.
I've often thought that we could do some, first of all, the mitigation. Those things are not mutually exclusive.
Right.
We do several of them at once. And I know a lot of people have a tendency to feel that a lot of that is, well, if you're going to do this, then you can't do that. Not true. You can do them all at once.
Yep.
I've also thought about a mitigation thing that I've never heard anybody talk much about. The amount of wheat and other cereal grains that we grow in the plains, and they don't do a whole lot. You can see it on a time. You can see where we get more oxygen and less CO2 is, some CO2 is absorbed, etc. But if we were to reforest that with nuts that could be used for our bread, not monoculture, so that we wouldn't be subject to a disease wipeout, maybe 5 or even ideally 10 species of nut trees, even if they had to be genetically tweaked slightly. I'm not for, integrating alligators into oak trees.
Sure.
But nonetheless, I would think a couple of things would happen. We wouldn't spend we'd spend a lot less fossil fuels getting our agriculture done than we do with combines in formation going across North Dakota, because tending to trees with tractors would be a whole lot smaller tractors, and you'd only plant them once every 35, 75, 100 years. What do you think?
So in my former life, as part of my long, illustrious work career, right? He was giving me a hard time about young people saying that. My previous job, I was working more on projects like that, on the mitigation side of forestry. You guys have maybe heard of carbon credits or carbon offsets, right? So that kind of scheme would be one way to incentivize that. If you could give people actually a little bit of a financial carrot based on the carbon that they're saving to do that sort of thing. And those kinds of agroforestry projects, those are acceptable. There are accounting protocols in place to give people carbon credits for doing that kind of work internationally. We don't have that sort of an accepted protocol for a market in the US yet, but there are examples out there like that. And even, maybe even as a halfway measure, just planting a winter cover crop. You know, I'm from Iowa. I was down there in the wintertime and see kind of a patchwork now. Some of the fields are bare, fallow, but then some of them have winter rye growing on them as a winter cover crop. And that is probably doing some good things for soaking in carbon and restoring soil fertility. So,
I've seen some articles on the internet about a company that builds these gigantic machines. They use waste heat from industrial power plants and so on, and they use it to produce CO2 for capture it for sale and for use. But they're immense devices, and it's not that it doesn't work, it's not that it's not, you know what I mean? It's, yeah, okay, but we've got these nice green things with the brown sides on them, you know, and they kind of just go by themselves. You don't have to wind them up or anything. So I've always been saying, we've got trees, we don't need to invent a machine tree.
yeah, well, and that's one of the, I mean, so the president released his climate plan, and one of the pieces of that is to reduce our greenhouse gas emissions. Most of that is through energy production, but a portion of that is coming through land management and forestry. So that's one of the things the USDA as a whole is increasingly looking at, because now we have a mandate from the president to explore this kind of stuff. So, yeah. Purple?
Yeah, thank you. What about that soil amending? I think that's the first time I've ever seen anybody trying to do that on a massive scale. I mean, talk about doing that in gardens, but often you find somebody taking a large scale property and then trying to put that sort of thing in it. I mean,
Yeah.
that's got to be quite an undertaking. And if you didn't do that, what other native species could you put back there in what is basically a sandy soil?
A couple of good questions. So, to our knowledge, this is the first time anyone's done it on this scale in a forest.
Well,
Farmers have been doing this sort of thing, even at large scales. I didn't mention this, but it's biochar, compost, and there's a third thing that they're adding to these soils, which is wood ash. And they're getting that from a paper company, paper mill, right across the border in the UP. That paper mill, years prior to this, they've been giving away that wood ash to farmers. It's a waste product for them. So they've been trying to give it away. And so farmers have been spreading it on their fields. And so now they donated it up to us for this project. So we're testing wood ash compost biochar. Your second question, what could you do here if you didn't do soil amendments? I think they still would have tried to transition this to a pine site. So we still think that that pine is probably going to have a better chance for success here. Our hope is that this adds to that. And they're not going exclusively pine, they're also trying to replace some of that mast that they're losing with swamp white oak and some other shrubs that are providing some of those benefits.
And the pines grow up, they might help build up the soil to the point where the oaks could come back.
Yeah, you see a lot of oaks coming in under red pine plantations right now, so yeah, it's not an exclusive thing. Yeah.
One of the things I fear is that climate change makes things change so quickly that our adaptation cannot keep up. And these are good efforts, but it's Herculean what must be done, to adjust to the changes that are occurring.
Yeah, particularly if we end up following that extreme pathway of climate change. If we end up in 100 years being 10 to 12 degrees warmer in Wisconsin, then
Goodbye winters.
then yeah, some of this chinkapin oak, maybe we should have been doing it 20 years ago. But actually, we still have, I try to be an optimist. We still have a huge amount of choice as citizens, as a planet, in where we end up in that spectrum of plausible outcomes from climate change. So there's a lot we can do still to steer ourselves towards that low end of the climate change spectrum. Yeah.
One question is, okay, so heat is good for agriculture, but too much heat is not.
Right.
How about CO2 fertilization? I think I've read or heard something recently that there is a limit to how much CO2 acts like a fertilizer in the forest. Can you talk about that a little bit?
How many of you are familiar with this idea of CO2 fertilization? Okay. More than in my usual audiences. I'm going to go back to this so I have something to talk about. CO2 fertilization, if you remember your plant physiology classes from high school or college, is a cross-section of a leaf. Okay, so outside of a leaf, inside of a leaf. And trees and other plants are soaking up CO2 passively, putting it in their photosynthetic machinery, and then creating biomass and fixing carbon. Okay, so with more CO2 floating around in the atmosphere, we're putting in more CO2 every year. We're basically adding more food to the buffet table for these plants, right? They have an enriched environment. So there have been some field trials that have tested this over decades. And yeah, if you pump in a lot more CO2 in a growth chamber where trees are growing, then you get increased growth. And I think an experiment in Rhinelander in an aspen forest, it was something like 26% increase in biomass compared to a control over 12 or 15 years. So not an insignificant benefit, potentially. Another benefit here is that there's some indications that trees can actually be more effective with their water if there's more CO2 floating around. And that's because anytime a tree feels a little bit of moisture stress, those pores were open and now they're pinched shut. They close up their leaf pores, so that protects them from losing water. But what happens is they run out of CO2 eventually and they have to turn off their photosynthesis, right? So they have to become stagnant. But if they have had excess CO2 floating around, chances are they've already absorbed excess so they can keep their photosynthetic machinery running longer through that period of drought. So those are two benefits. Now, like you said, this is not a runaway gravy train into paradise. There is a limit because pretty soon, even if you have all the CO2 that you could ever want as a tree, something else is going to become limiting, like water or any other soil nutrient, nitrogen, phosphorus, you name it. Right, so there's limits on how far this increase can go. Is that helpful? Yeah.
The CO2 could also benefit other plants which would be in competition with whatever you have in mind.
Yep.
And so therefore, if the other plants are more efficient at processing the CO2, your whatever plant you're in favor of is going to lose out.
Yeah, these things don't occur just in a vacuum. And actually, there's some recent research. This co-chair paper has actually showed that other stressors are keying into this too, like insect pests. And they actually found that in some of these growth trials, insects ate more leaves of these aspen that were growing faster. And they're not sure why yet. They're not sure if there were fewer nutrients in those aspen leaves because they were growing so fast. They had, poorer nutritive value. So maybe the insects had to eat more. They don't know yet.
Is there such a thing as CO2 saturation? Usually in some chemical process, there's a limit how much that process can absorb. By putting sugar in your coffee, eventually you run out of coffee.
Yeah, you can say that because something else is going to, in this case, something else would limit the amount of photosynthesis you could do as a tree. Yeah.
I'm just curious, so you're dealing with municipalities as well as private landowners and things. This whole climate change thing is so politically charged. Are you finding that, like municipalities, people that work with you have a hard time with, the electorate supporting what they're doing? I mean, this is all around us, this is science, and yet it is very political also.
It is?
I mean, do you see this in your work?
Yeah. in a couple of ways. So before today, I spent a couple days in Wisconsin Dells with the entire Division of Forestry, or the Wisconsin DNR, talking about climate change. I had 3 hours in their annual statewide meeting, which is pretty cool, right? Which you might not expect if all you listen to is the talking heads up above. And that's usually the case. So even when we get in these kind of challenging political environments, people on the ground are ready for this information, are ready to start trying things, are concerned. So as long as we can do it in a way that is sensitive, and we focus on the values that they have, so we're focusing on forest health, focusing on things that are meaningful to the population, then it makes perfect sense to be talking about this. Now, if we got up there and waved a flag and banged a red drum and saying, "Hey, we're solving climate change and Wisconsin DNR is helping us do it," we would probably attract a lot of unnecessary attention. But I would say there are always ways for us to work, and we've been pretty lucky dealing with that.
Well, Stephen is going to stay all night in Stevens Point. He's not going to the Uper country. So you can stick around and talk to him, but we've got goodies over here. Sue and Lenore have provided them. And so help yourself, ask questions of Steve. Thanks again.